So the next part is the semaphores. Semaphores, the meaning of the semaphores, we have seen the logs and the condition variables. They can help in solving a lot of the synchronization issues and data race. So Dijkstra is a person. He invented semaphores as a single solution for all the synchronization problems. That's a big contribution. And a semaphore is as an object with an integer value that we can manipulate with two routines. And in the POSIX, these routines are means the function. These routines are wait and post. For the semaphores, in the first thing we need to do is initialization. We declare a semaphore S and initialize it to the value 1 here by passing the 1 as the last argument. And the second value is 0, is set to 0. That means it's the semaphore is shared between the threads in the same process. And this argument can be changed according to the different processes, but in this example, we use the shared only in the same process. So there are two functions, sem wait and post. They have different usage here. For the wait, it decreases the value by 1 and the semaphore value. It only takes effect when the value is 0. And for the post, it increased the value by 1. That's how it works here. The wait will decrease, and when we call the post will increase. So for binary semaphore locks, we initialize the x to 1. Here is the semaphore value to 1. And if the thread, this initial value, and then if the thread is 0, they call the wait, call this function, and then it will decrease the this semaphore value by 1. So it becomes 0 now. And then the finished returns. And next step is for the function. It can access the critical section and do some changes to this section. And after this operation is completed, then it will call the post function, which means it completed already completed the operation. And then when they call the post function, it will increase the semaphore's value by 1. And during the value of the semaphore is 0, if we have the thread 1 want to access this area, it's impossible because it cannot be less than 0. So in this way, this value limit the access right for the threads. When it's 0, it cannot be decreased more. So the more threads cannot access the critical section. Let's say if we have multiple threads, for example, in this case, we have 3 threads and the semaphore's value is 2, the initial value is 2. So for the first thread, thread 0, it calls wait, which means we decrease the value by 1, and then it will access the critical section, which means it will do some operation on this area. And then we have the second thread, it's thread 1. It wants to use the critical section. It calls the wait, then the value of semaphore will decrease by 1, it becomes 0 now. And also it can access this section now. So at this moment, both threads 0 and 1, they are using this section. At this time, if more thread, the third thread want to access this area, so it will call the wait. But the value is already 0, it cannot be decreased more. So it have to wait. It cannot access the section now. In this case, we can prevent the third thread to access the critical section. And after that, you can release and increase by 1 and release increased by 1. So in this case, we can see the value of semaphore. What does it represent? That means it represents the number of threads can access the critical section. If number is 2, that means that at most 2 threads can access the critical section simultaneously. The third one you cannot access. But one situation is that when the first thread released the value, that means there's only one thread on this section. Here, if the third thread want to access, it's possible because the value is 1 now. It can keeps decreasing to 0.